Welcome to Web Handling. My name is Dave Roysum. I am super excited to begin a new series on web handling, past, present, and future. In this short clip, we will define web handling and demonstrate why web handling is important to you. A web is long, thin, and flexible. All webs follow the same laws of physics. This is convenient. This means you do not have to learn one set of rules for a thick film and another for thin film. You do not need to learn a different set of rules for paper, film, foil, nonwovens, and even textiles. They are all the same. If you see a wrinkle, for example, you diagnose it using the same set of tools, no matter whether it is on paper or film. If you see a web break, you diagnose it using the same set of tools, no matter whether it is on foil or paper. If you see a wound roll defect, such as telescoping, you diagnose it the same way, no matter what the chemistry. This is convenient. One set of rules for all materials. Look around you. The room you are in may have 10, 20, or even 100 different web materials. Paper is the oldest web material. Though it is more than 2,000 years old as a sheeted material, it was 200 years ago that paper was first made as a web. Paper is also the largest of the web industries. As the oldest and the largest industry, we should not be surprised to find that it has many resources and has pioneered much. Many of our lab tests, such as for strength and for thickness, originated in paper and were codified by paper organizations such as TAPI. Many of our mechanical components, such as the ubiquitous roller, were first tried and tested in the paper industry. Many online measurements, such as for web tension and for thickness and for optical detection of defects, originated in paper. No matter what material you make, your heritage is the paper industry as much as any other. That is not to say that other industries have not also contributed. Much of the science of air entrainment, winding, and wrinkling began in the film industry. Foil teaches us that even the tightest of conventional roller tolerances may not be good enough for thin materials because they are so stiff. Nonwovens and textiles teaches us that one size does not fit all for tolerances. These more flexible materials can tolerate much more before quality suffers. Each material has something to teach us. There are uncountable products made as webs. It may surprise some of you that fiberglass batting is made on almost exactly the same type of machine as is paper. It may surprise you to know that cigarette tobacco is also made on something like a paper machine. Perhaps most surprising, that a wide variety of food products, such as pasta or potato chips, may be made as a web. We all have much in common. What web handling has done is to bring a diverse set of industries together to work on a common set of problems. Web handling is the art and science of getting a web through a machine as fast as possible and with a minimum amount of troubles. At its roots, much of web handling is a science. This means that we can sometimes write the equations for some of the simpler behaviors. However, most people misunderstand science, including scientists, and they may be put off by it. They think that you need to pull out a calculator or a meter to do science. Not necessarily so. Science teaches us three things: which knob to turn for a given problem, what direction to turn those knobs, for example, is up better than down, and finally, how far to turn those knobs. It is this last thing, how far to turn the knobs, that is the most expensive part of science. However, couldn't we get most of the benefit by merely knowing which knob to turn, so that we don't waste our time with factors that are less likely to be successful, and what direction to turn those knobs, so that we speed up the troubleshooting process? What about the how far to turn the knob? How do we get that in the real world? Simple. Turn the knob. And if it doesn't get you far enough, turn it farther until you fix the problem or run out of knob. While much of web handling is a science at its roots, some areas are too complicated even for science. The whole subject of slitting, by which I mean cutting of webs, is so complicated that even the simplest method, razor slitting, has no modeling success, despite many attempts. Nonetheless, we still know much about slitting because we have billions of slitter blades in service. Thus, web handling is a blend of art, craft, and science. So, why study web handling? Simple. The same reason we do most everything in business: to make money. So, why study web handling? Shouldn't it be easy, you say? Just put a brake on the unwind and a motor on the wind-up and drag the web through the machine. Perhaps if you had carpeting or steel, maybe it might be that easy. However, even tough materials like carpeting and steel have web handling problems, including wrinkling and web breaks. Look at this list of troubles, including baggy webs, curl, dimensional control such as length and width, position control such as registration, web breaks, winding defects, and wrinkling. How many of those problems do you or your customer have? I would bet that many of you have many of these problems. I would not be surprised if some of you have all of these problems. I would not be surprised that if some of these problems were in the top 3 causes of waste, delay, and customer complaint in your plant. These are the problems and others that are common in all the web industries. So what does it take to be a good web handler? These are the subjects that are taught in my award-winning and trademarked Web 101 class that has been taken by about 5,000 students. We first start with rollers, the building blocks of our machines. Then we move from mechanical to controls topics. 3 of the big web handling controls are called the TNTs. These are tension, nip, and temperature, or moisture in the case of materials such as paper. Then we follow with guiding. Next, we teach about wrinkling and a related topic, spreading. For some of you, this may be the most important area because wrinkling-related troubles are often in the top 3 causes of waste and delay. Finally, we talk about must-know converting topics of slitting and winding. which are also areas of big troubles in our plant. Finally, every good web handler must also be a good problem solver. This is covered in a separate set of course materials, as well as dozens of YouTube clips on my all web handling channel called 201, as well as 2 books. We will not study manufacturing here for 2 reasons. First, I am not a manufacturing expert, even in the paper industry where I have spent much of my 40-year career. Second, it would make this course way too long. We already have a lot to do. Even so, the good web handler will know whether the paper maker has done his job right, even better than the paper maker himself does in some cases. Even so, the good web handler will know whether film extrusion is level and uniform, even better than the extrusion department does in some cases. Why? Because we are their customer. If it isn't flat, it isn't uniform, we are going to see web and winding troubles. We will also not study converting here, even though these topics are quite important too. First, I am not a converting expert, even on coders, upon which I work on several times a month. Second, it would make the course too long. We already have a lot to do. Even so, the good web handler will know whether the coding is uniform, even better than the coding department does, at least in some cases. Why? Because we are their customer. If the coding isn't uniform, we may see web and winding troubles. What we are going to study here is web handling. Here, we don't make materials and we don't change materials. Instead, we try to preserve the web. In other words, get it through the machine without damage and without troubles such as we listed earlier. Thank you so very much for letting me share this extended introduction to web handling. I trust that you now see what web handling is and why it is essential for most people in your plants to know something about it. Stay tuned for the next segment where we will briefly outline web history and why it matters to you today.